We want to go to Mars as soon as possible, but using energy for things like video games can make it take much longer. Does that mean you are supposed to save every bit of energy on Earth so you can one day die on Mars? Or do we already have enough energy sources to sustain life on multiple planets? But for now, the most important question is, when are we finally moving to Mars? First, we need to understand that sending spacecrafts, probes, or robots to a planet and taking humans to another planet to actually live there are two total different things. The former is considerably easier, and we've already done that. Here's Curiosity rover saying hi to you. But why it's easier to send a robot than a human? Well, obviously a robot doesn't require food, water, and oxygen. The idea of colonizing Mars has always fascinated us. We wrote tons of books about it, made movies, art pieces. But why are we still not there? Scientists and visionaries have been talking and suggesting oodles of plans about it for decades already.
The likelihood that you personally will go to Mars?
70%.
With the development of new generation rockets and more interest in space exploration, we have never been closer to fulfilling this dream than we are today. But still, every prediction that says we are going to Mars within the next 5 years seems to keep failing and failing. So what makes our red neighbor so hard to reach for us? Well, the researchers say that if we can overcome the challenges that are waiting for us, we could potentially transform into a species that spans the cosmos in about 200 years. After all the plans we heard, this might seem really far future. But maybe it's better than an empty promise, because it seems like we ain't moving anywhere anytime soon. Becoming multi-planetary species has so many requirements. Humans must start diligently escalating nuclear and renewable energy use, all while coming up with better methods to save these energy fonts from exploitation. So exactly how much energy we must have to achieve our Mars goal? Here's a little history to explain the concept to you. Back in 1964, a Soviet astronomer, Nikolai Kardashev, laid the foundations of a measurement scheme, later refined by Carl Sagan. Basically, this Kardashev Scale is a method of measuring a civilization's level of technological advancement based on the amount of energy it can harness and use. It's a way to classify and understand a society's progress by looking at its energy utilization capabilities, ranging from lower levels like Type 0 to higher levels like Type 1, 2, and 3, which represent increasing mastery of energy sources, including those beyond Earth. It's the measure of how advanced a species is at harnessing energy, regardless of its source, in order to fuel its pursuits, whether it's the quest for space exploration or the pursuit of a fun video game. Imagine for a moment, a Kardashev Type 1 civilization can tap into all of their planet's energy resources and store it for their needs. They might even have the power to influence natural events like earthquakes and volcanic eruptions. For a Type 2 civilization, they have the ability to directly use the energy from a star, often done by constructing something like a Dyson sphere around it. In the case of a Type 3 civilization, they can capture and utilize all the energy emitted by their entire galaxy, including energy from stars, black holes, and other celestial objects. So you can say that humankind isn't even Type 1 civilization yet. Yet our big appetite for energy grows year by year. More individuals demand greater power per capita, and it's a dynamic progression. But this increase is not without its shadows. Here comes problems, like harming our planet and the risk of dangerous uses of nuclear weapons. If we can somehow manage to reach Type Y, there'd be other obstacles on the road. So, we need to navigate carefully as we use more energy. We want to explore beyond our solar system, and this means gathering huge energy reserves, not just for temporary bases, but for building those futuristic cities. The journey to become a multi-planetary species is an energy-driven adventure. A study suggests that by using more renewable and nuclear energy, we could shift away from fossil fuels in the next few decades. If we keep this up, we might reach Type 1 civilization status by 2371. Let's see, where are we standing in our space journey today? Even though there are multiple places we can technically go in solar system, Mars is our best option, since it's the only planet within the habitable zone around our sun and the closest terrestrial object to colonize. Good news is we already started exploring our future home. Well, maybe. But after all the successful Mars rover missions by both NASA and China, the question remains, why haven't humans reached Mars yet? The first challenge is the vast distance to Mars. The red planet is 55 million kilometers away at its closest point to Earth. However, this distance isn't fixed because Earth and Mars orbit the Sun at different speeds and distances. This means there are specific times that are better for traveling between the two planets, especially when considering the goal is not just to reach Mars quickly, but also to return. What makes it really challenging is that opportunities to travel to Mars occur every 26 months. Technology is a crucial factor here. Most rockets we've used for space travel rely on traditional rocket fuel, which takes up a lot of space and isn't ideal for longer journeys. Here comes SpaceX's future plans about refueling a spacecraft up in the open space. But there hasn't been a huge improvement there yet. Even though the fully stacked Starship orbital test in April 2023 gave us a glimpse of hope before it exploded. It seems that there's a lot that needs to be improved. In addition to technology, there's a need to understand how humans, who have evolved to thrive in Earth's atmosphere and gravity, will adapt to the challenges of living in a confined, low-gravity environment, where there's no water on surface and no shield from all the radiation from the sun. But challenges of living on Mars is the topic for another video. Research involving how astronauts on the International Space Station cope with isolation and low gravity, as well as how they readjust when returning to Earth, are still ongoing. Lunar missions have also provided insights into how astronauts handle low-gravity environments. Getting to Mars's orbit is only part of the challenge. Safely landing on the red planet poses another set of difficulties. While the development of fully reusable Starship can tackle this problem, but we already talked about improvements that are needed. NASA, on the other hand, is working on developing an inflatable decelerator, similar to a reverse parachute, to protect and slow down landing craft as they enter the Martian atmosphere. Regarding equipment, any human mission to Mars would likely require a prior cargo delivery. Certain things would be placed and tested before committing to sending astronauts, so it is likely that we'll see a human walking on Martian soils within this decade. But becoming actually multi-planetary species is the actual challenge, and this can take more than a century, especially if we take into consideration that we already been to Moon but stopped going there for half a century, and no one really knows why, except for politicians probably. So what's going to happen after we first visit Mars can't go further than a mere prediction, and we don't happen to be very good at it. What do you think about moving to Mars? Is it possible that your grandchildren might go to school on another planet? Share your opinions with us. Before you go, maybe you want to watch a video about the evolution of Starship, aka our biggest hope about future. Thanks for watching till the end, and see you on Mars or in the next video.